участников и слушателей за подготовку, за высокий уровень, за желание что-то узнавать новое и идти дальше, да, с новыми целями и достигать каких-то новых вершин научных и личностных каких-то. Спасибо всем.
Спасибо. Эдуард Апетнакович, вы хотели бы что-нибудь сказать?
Я вот, что касается Юлии Андреевны, буквально 2 слова. По сути дела, ею выполнена очень кропотливая работа в плане вот, определения аллергии к лимону. Это имеет большое значение. И, собственно говоря, ей уже пора выходить на защиту кандидатской диссертации. Вот то, что я хочу ей пожелать. И мы этого ждем. По предыдущей работе, вот Танзеля и Мэри, да, очень прекрасная тоже объемная работа. Хотелось бы, конечно, дальнейшее продолжение, потому что на данном этапе они сосредоточили свое внимание на белках, жирах, на углеводах. Есть тут определенные пугающие и тревожные результаты. Тревожные для наших детей, для наших студентов. Стоило бы, наверное, более внимательно обратить свои взоры на макро- и микроэлементы, потому что это тоже серьезная проблема. Я вот краем глаза успел обратить внимание на содержание кальция, потребляемых продуктов, снижение потребления калия. Там я, довольно быстро таблица прошла, не все можно было оценить, но, в общем-то, заметно, что очень некачественное питание наших студентов. Это выливается и в сердечно-сосудистые заболевания, и в эндокринные заболевания, и заболевания желудочно-кишечного тракта, почек и так далее, и так далее. То есть практически все то, о чем мы сегодня говорили, в большинстве случаев потенцируется именно погрешностями в нашем питании. Поэтому я тоже желаю продолжения работы, в общем-то, и в дальнейших докладах, в дальнейших публикациях по данной теме. Спасибо.
Спасибо, Эдуард Апетнакович. Коллеги, я еще раз хочу поблагодарить всех докладчиков, особенно наших гостей, и за интересные доклады, за очень такие серьезные проблемы, которые вы подняли в своих исследованиях. И мы не отключаемся сейчас, мы продолжаем все быть подключенными, и сейчас временно паузу мы берем до выступления нашего уважаемого профессора Грегора Рейда. Поэтому все сохраняем внимание и готовность слушать уважаемого профессора. Спасибо всем.
Спасибо, Мурат Анатольевич, спасибо, Лилия Вячеславовна, спасибо, Эдуард Апетнакович, за блестяще проведенную вашу секцию. Было интересно, познавательно и приятно. Хорошая деловая атмосфера. А сейчас мне хотелось бы предоставить слово модератору нашей следующей секции, Владимир Владиславович Смеянов, Северокавказская государственная академия. Именно благодаря ему мы сможем иметь возможность слушать такого именитого ученого. Поэтому, Владимир Владиславович, пожалуйста, выходите на связь. И мы попросили Владимира Владиславовича сделать небольшое вступление, немного рассказать о нашем лекторе. В дальнейшем возможность... Доктор Грегор Рейд говорит, что он хочет дискутировать с аудиторией, и возможность задать вопрос может быть и на английском. В то же время вы можете задать вопрос на русском в чате, и наш модератор постарается нам помочь и будет переводить ваши вопросы, чтобы это было максимально эффективно и хорошо, и каждый получил свой ответ. Владимир Владиславович, вы здесь?
Я здесь. Я здесь.
Микрофон ваш.
Да, я здесь. Здравствуйте, уважаемые коллеги, добрый вечер. Good morning, Dr. Reid. I already saw you here.
Good morning, can you hear me okay?
Good morning, yes, yes.
You look very distinguished. You look very distinguished, Vladimir.
So first, I will give the introduction in English, then in Russian. Just very short. So, dear students, residents, medical residents, professors, doctors, dear colleagues, I'd like to introduce you Dr. Reid, who is a professor at the Western University in Ontario, Canada. Dr. Reid is a prominent microbiologist who pioneered the field of probiotics in particular for women's health, and in particular the usage of probiotics for the treatment of urinary tract infections and, let's say, bacterial vaginosis and other conditions, namely lactobacilli and probiotics. So beneficial bacteria, in this case lactobacilli primarily, or what we call now probiotics. Dr. Reid also has made outstanding contributions in the field of study of human microbiota, in particular microbiota of urogenital tract and gastrointestinal tract. In health and disease, he authored more than 500 papers in peer-reviewed journals and more than 28 patents. He holds more than 28 patents, and his H index or Hershey index is 109. And what matters for our current conference, Dr. Reid supervised a large number of students, starting from bachelor students, medical students, PhD students, postdoctoral students, and therefore he has great experience in medical education, biological education, and raising of young scientists. So the name of his talk would be, what does it take to succeed in science? Exactly is the theme of our current conference. And now in Russian. Уважаемые коллеги, студенты, ординаторы, аспиранты, преподаватели, профессора и доктора. Я хотел бы вам представить доктора Рида, который является профессором Западного университета в провинции Онтарио в Канаде. Доктор Рейд является выдающимся микробиологом, который внес вклад первооткрывателя в области пробиотикотерапии для инфекций мочеполового тракта у женщин, в частности хронических циститов, уретритов, а также бактериального вагиноза. Кроме того, доктор Рид внес выдающийся вклад в изучение нормальной микробиоты мочеполового тракта и желудочно-кишечного тракта. Является автором более 500 работ, рецензируемых в журналах и монографий, и более 28 патентов. H-индекс 109. Доктор Рид руководил в течение своей научной карьеры большим количеством студентов, начиная от бакалавриата, магистрами, соответственно, PhD студентами, постдокторами, и, соответственно, обладает огромным опытом в образовании кадров для медицины и научных работников. И в этой связи доктор Рид любезно согласился представить доклад под названием в переводе «Что требуется для достижения успеха в науке». Давайте поприветствуем доктора Рид, and let's give him an opportunity to give a speech. Please, Dr. Reid, everybody is ready to listen to you.
Okay, can you see my screen, Vladimir?
Yes, it will. Yes, yes, yes.
Okay. Thank you for the introduction. It's interesting that I have been to Russia, as you can see from the photograph, and a couple of things I found quite interesting. First of all, your language. When I see people on the screen with your names, I have no idea what your names are. It's the strangest language I've ever seen. So thank you, Vladimir, because you wrote your name in English. So, and when I was in Moscow, I couldn't find my way around because in China, when you look at language, you can almost picture a place like on the subway, but for Moscow, because I couldn't understand it, it was difficult. And the other thing that happened, I was with a group of Canadians and we were at dinner. And I'm hoping that you can understand me. I'll talk slowly so that you can understand me. But so we were at dinner and the Russian group were all sitting on one side and the Canadian group were sitting on the other side. So I went up to the Canadians and I said, look, why are you not sitting beside the Russians? And they said, well, you know, we don't understand the language very much and Russians don't have a sense of humor. So then I went over to the Russian side and I said, why are you not sitting with the Canadians? And they said, well, Canadians don't have a sense of humor. So it's just misunderstanding. And once people get together, people are people. And so thank you for inviting me. And it's exciting to talk to you. Now, I'm not going to talk about microbiology on its own. I'm going to talk to you about how do you get from a young scientist to a successful innovator. And I think there's three ways. And the reason I'm not talking just microbiology is because I know that not all of you are microbiologists. So there's three ways that you can become successful. One way is to let other people innovate and you just simply implement what they have invented. The second one is if you get lucky and it just so happens you're in the right place at the right time, and that's what I would call luck. And the third one is that you plan it so that it isn't luck. You are making your own luck. So I'm going to start off with this. I don't know if any of you are in the medical field, if any of you have seen what it looks like inside of someone's knee. This is my knee. It's my right knee. And can you see the arrows, Vladimir, when I'm showing the arrow?
Yes,
Okay.
yes, I can see it.
Right. So this area here you can see is pink. This is bone, right? So on my knee, there's lots of bone, which is not good because it means that when I'm rubbing my knee, it's bone on bone. So bone is hitting bone. What should happen is this material here, which is cartilage. So all this should be covered in white. Why am I telling you this? One, because I want you to feel sorry for me because I'm in pain all the time. But the reason I'm doing it is the resident, the medical resident said, if you could find a way to replace cartilage, you'd be a billionaire. In other words, if you could find a way to put this material back so that there's no more bone on the surface, you would be a billionaire. There are so many people in the world who have bone touching bone, right? All right. So let's look at number one option, let others innovate. So this is a company in California. And what they've done is they've said, how do we fix this knee? So we are looking at adult stem cells. And they have come up with a way, these adult stem cells, they affect this WNT pathway. So this is the drug, essentially. It's a novel intra-articular CDC-like kinase 2 dual-specific inhibitor, right? And the pathway is to treat the osteoarthritis. And so they're doing a randomized trial. And this is what it looks like. It's actually pretty exciting. This is pain. And when you see the pain with placebo versus the drug, then clearly the different doses of this drug are working. And this was published in 2020. Now, what's this got to do with you? Well, it means that, for example, if you are a surgeon or in this case, a musculoskeletal surgeon, you're not innovating. But what you could do is you could go to this company and get this drug and be the first people in Russia to test the drug to see if it works. So in that way, you're still a researcher, but you're implementing rather than innovating. This is not your discovery. So, do you know surgeons to perform studies and evaluate the technology? So you hear about this technology and you go to the surgeons and you say, look, let's try this in Russia. Well, you have the patients, you have the clinics, you have the physiotherapists for post-care. In other words, you have everything to do to test this drug. Is there clinical trial expertise in your institute? Well, if there isn't, you have to find it. In other words, you go to the company and you say, look, come to us in Russia, we will be the best ones to test this new technology, and we could implement this for athletes and older people who have problems with their musculoskeletal knees and hips. But how satisfying is it if you test someone else's product? I mean, it's always nice to be first to test a product, but what happens if you were the one that designed the stem cells? So are there people around you who might come together to make their own innovation? So therefore, what you would do is you say, oh, I have this idea of using stem cells to try and repair the cartilage on the knee. I wonder who I need to collaborate with. Well, maybe there's someone in your institute working on stem cells. Maybe there's a little spin-off company that's working on stem cells. So this is your university, right? And it says our medical faculty is one of the best in the country. That's what you're telling the world. So if you're telling the world this, that means that you have a lot of really good people in your university. And that means that you can go to them and say, look, I have an idea, but we need to collaborate. And I'm going to show you later on the extent of collaboration that I did, which helped me in my career. So could you have developed and tested these, and who would your partners that you're missing? So let's give an example. This is a thing called the Marvel. It's a multi-angle rear viewing endoscope with 3D high definition. I don't know if you know what an endoscope is, but if you think of keyhole surgery, so you get a tube with a camera and sometimes it has different things on the end, and you go inside the body. Well, this particular invention is a 3D high definition one. Well, I haven't been to Russia for a long time, but you have some very talented scientists, and I bet you're working on 3D high definition technology. So all you need to do is to find the people to then bring that into medicine. Here's another one, it's really cool. Smart surgical glasses, live streaming with distant colleagues. Okay, so you imagine I'm in the operating room and I've got glasses on. Well, the glasses have a special camera on the end, and the camera, I'm just a young resident, I'm not very experienced. The main surgeon is Vladimir. But Vladimir is in St. Petersburg and I'm in Moscow. So I need his help. So I put these glasses on and it sends the message to Vladimir, and he is essentially doing the operation, but I'm the one looking at the patient. So in order to do that, you need to come up with using your imagination. You need to think of glasses. You need to think of the technology that goes on the end, the camera, the lens, the computer that sends it to Vladimir in a way that he can then see it clearly. None of that is difficult. It just needs the right people to come together and do it. And then you can imagine that technology could then be useful around the world. And certainly in a country the size of Russia, which is a huge country, you can't possibly have expertise in Siberia when the expertise is in Moscow. But if the people in Siberia have these surgical glasses, they can still do the same operation. Here's another one. This is surgical robots. So there's a surgeon in Saskatchewan, which is in the middle of Canada, and he's very often away, but he has a robot, and the robot walks around the hospital and looks at his patients. Imagine then if you have a surgical robot. So right now, I need to have an operation on my brain. The robot actually does the technology, and you are the surgeon, and you again could be in St. Petersburg, and the robot, and you're controlling the robot, and it goes into the brain, and artificial intelligence means it finds where the cancer is, and it treats the cancer, right? This is a robot. Now, that means artificial intelligence. You need to collaborate with people in artificial intelligence. You need to collaborate with engineers. You need to collaborate with people who do the imaging. You need to collaborate with a physician or a surgeon who can help do this. So you see how such a simple technology it sounds like, but it involves many, many different people. And this is why your careers could be very exciting. Don't think of yourself as going down one path. There are many, many paths that you can follow. Remote robotics for percutaneous coronary intervention. So, I mean, you may have seen in the Netherlands that they have a drone that if you have a heart attack, they can send a defibrillator in a drone to you faster than the ambulance. So that's one extreme of using that technology, but this is remote robotics to do heart intervention. So someone has invented this. A blood test for breast cancer 5 years before the lump. So how many people get breast cancer in Russia? I bet you it's a lot of people. And imagine if 5 years before that, instead of the terrible mammograms, which are uncomfortable, I don't know really how reliable they are. Imagine if you had a test that you could, a woman could take every 5 years, and it would predict whether they were going to get cancer. That would be cool. In order to do that, you can imagine you need somebody who knows technology, you need the engineer, you need the molecular biologist, you need the cancer expert, etc., etc. Drugs are blockers, non-opioids that target pain receptors. So these are all inventions, by the way, that are actual, they're real. So you probably know that in the world, certainly in North America, the use of opioids for treating pain has resulted in many, many addictions. And a lot of drug addicts are dying, hundreds, if not thousands, every single year because they overdose on drugs, opioids that come from China and are not well made. So imagine if you had a non-opioid painkiller. And then there's two more, patient-specific devices. So, okay, imagine they say to me, Gregor, you need a new knee. Now in Russia, you have people who get new knees and new hips and new elbows, new shoulders, but they go over and they say, okay, this one looks like it fits. This is pretty good. We're going to give you this one. No, 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 no. I don't want one of the 10 that the company has developed. I want one that fits my body. And so in the operating room, the surgeon and the scientist, they use a 3D printer and they make my device specific for me. And then a new approach to glioblastoma. So glioblastoma is a brain cancer with no treatment. And there's many ways that, again, you could consider what causes it, how you prevent it, and how you treat it. So I hope you understand that these are examples of using other companies' innovations, but also a way that you can become innovative. The second is get lucky. So at an undergraduate scholarship interview 7 years ago, I told the selection committee that I wanted to be lucky scientists, and they laughed. This is not me, this is a story that is from someone else. I'm a great believer in luck. I find the harder I work, the more luck I have, right? Luck is about hard work. If an opportunity doesn't knock, build a door. Isn't that great? No, the hard part about doing Zoom conferences is I can't see your reaction. So I'm hoping that some of you are laughing at that analogy. If the opportunity doesn't come, build the door and then you knock on the door. By using all the resources of a research community, scientists can be better prepared to serve luck. So for luck to happen, you have to be prepared to accept the luck. Right. So here's an example. This is Bacillus calmette-guerin vaccine. It was developed in the early 1900s to protect against tuberculosis. Well, the Murdoch's Children Research Institute in Australia is conducting a phase 3 trial called the BRACE to see if the vaccine protects against coronavirus. In other words, they had done work on a completely different area, but because they had used to working on vaccines, when the need came along for COVID, now they were ready. Well, that's luck. That's luck, but it also means that they were prepared for it. Here's another one here. A brief history of surgical therapies for Parkinson's disease. How science and serendipity contributed to advancement of surgical treatment in Parkinson's. Serendipity, I don't know if Vladimir, if there's a word in Russian that is the same as serendipity. It's kind of like being lucky in the right place at the right time. No? Okay. So you can look up this paper. It's kind of a neat paper of serendipity. And it's the Swan-Ganz catheter. So this is a catheter that goes into your body. How did this catheter get developed? Well, it's a kind of neat story. So sitting on a Santa Monica beach in America, watching sailboats, Jeremy Swan has a Newton apple flash of inspiration. Now, a Newton apple is when the apple fell and Newton discovered that that's what gravity was. So he's just observing and he had this inspiration. So a catheter equipped with sheets and sails could pass through the right atrium of the heart, the right ventricle, and then go to the pulmonary artery carried by the force of blood. In other words, he's sitting on a beach, imagining a sailboat and thinking, wow, imagine if that could go through the body. Well, someone suggests maybe the same effect could be accomplished by replacing the sails with a balloon, right? So what is this amazing catheter? What is it now? Well, it's a catheter that goes in and then you inflate the balloon and the balloon opens up the artery. That idea came from a guy sitting on a beach, right? That's lucky, but it's also him making the luck. The third area is planets, so it isn't luck. So can we engineer ourselves to be lucky scientists? I think the answer is yes. How do you measure success in Russia? If someone says to you, this person is successful, how do you measure that? Well, funding, okay? Can you help write grants? Can you help find industry partners that will give money for the lab? So even if you can't do it, maybe someone can help you. Experimental progress. So I love this expression, scientists can do it, surgeons can tell you why. So if you are sitting in your lab doing research that you think is important, make sure you talk to a surgeon or a clinician to see whether it really is important or not. Conceptualize the high impact manuscript. So a lot of times we get results and we quickly publish it in a local journal, a Russian journal or whatever. But if we did a little bit more experiments, we may be able to get an even higher impact, because if you get a journal that is worldwide, then your work will get noticed. Patient recruitment. If you're going to do a study that's relevant to patients, you have to have really good patient recruitment. And when I was in Russia, there was some studies that were done on probiotics, and they were small studies. They were actually showing some positive results. But the Russian scientists and clinicians never published it. They never continued to get a sample size that was enough for publication. So don't waste your time. Make sure you do something that will lead to a manuscript, because a manuscript is how you're going to be evaluated. This is me. Look how amazingly handsome I am in 1982. So this is my colleague, Dr. Bruce. And so back here, you can see this is a surgeon. He's a urologist. This is a urologist. This is a scientist. This is a scientist. And that's how we did it. So we had a study, prevention of urinary tract infection in rats in 1985. And all because of this urologist who said, I wonder if healthy people have lactobacilli, and then lactobacilli are helping prevent infection. So had I not been working with a clinical colleague, I wouldn't have had this discovery. So don't let anyone tell you it's easy. The president of the American Society of Microbiology, 1989, said probiotics may be today's snake oil, fraudulently peddled by hawkers from the backs of covered wagons. I hope you understand this in Russia. Imagine the president of a major organization telling the world that your work is like snake oil and that you sell it off the back of a wagon. This expert wasn't an expert in microbes. He was an expert in oil, and his work helped clean up the Exxon Valdez oil spill. So he didn't know what he was talking about. I figured that I would give him a response, and here's my response. The first probiotic delivery system off the back of a wagon, and here's me delivering it. So I was, of course, joking, but it's no longer a joke, because this is the Russian market for probiotics in 2020 to 25. The annual growth rate is 6%, and Russians are looking for probiotics on humans, livestock, fish, crops, honeybees, many, many areas. So you have an opportunity, if you want it, to look at studying the application of beneficial microbes, not only to humans, but to many other areas of benefit to the Russian economy. So the president of the American Society of Microbiology was a complete idiot. But back in 1999, people might have said, oh, he says it's snake oil, you shouldn't work on it. No. Don't listen to people like that. Don't listen to people who tell you what you can't do. Listen to people who tell you what you can do. So I studied the urogenital tract lactobacilli with Dr. Bruce, as I showed you. And then it took me to defining the term probiotics with the United Nations World Health Organization in 2001. And then it took me to a grant to studying a field that is now a $60 billion market with thousands of scientists. Now, I didn't plan this. I didn't look in 1982 and say, oh, I'm going to do this, 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 and this. I put myself in a position where I was with a urologist who I felt had really good ideas, and together things started to happen. So don't imagine that suddenly you'll just go straight to being world famous or anything like that. It doesn't work like that. And now, since then, I've worked on projects improving food and nutrition, where over 260,000 people in Africa are using probiotics because of some of the work we did. And this is some of the recent work where we're trying to save the honeybee. The honeybee is responsible for about 1/3 of the world's food production. But the honeybees are dying because of pesticides, because of pathogens, and because we're knocking down the territory and building houses. And so we've developed a technology, a probiotic, to try and help the honeybee. So follow your gut instinct. Right? What do you really believe you are good at? What are you really interested in? What gets you up in the morning and says, I want to go to the lab or my office. I want to work on this because I'm excited. Because if you're not excited, it won't be as happy a career. Plant a seed. You need to plant a seed. You can't just expect things to happen. You have to lay the groundwork by either getting the right qualifications or by getting the right collaboration, by doing things that, as I say, is planting seed. And believe it will bear fruit even when others will try to cut you down. People will tell you, you're not good enough, you're not smart enough, you don't have money, your ideas are bad. No, no, no. If you truly believe in your ideas, follow them. Don't listen to other people. And I like this, drive down the road, because you don't know what the road's going to be. You don't know where this road is going to take you. And so you have to get on the road and you have to start driving, and you have to have a car or a bike or your legs to start walking down this road. So the problem, honeybees, let's give you a couple of examples. Honeybees are experiencing persistent threats. This is the honeybees. This is them dying off. This is, normally you get about 15% of deaths. We're way up here, some cases 40% death. We cannot sustain this in the world. So colony collapse disorder is unsustainable. Why are they important? Because they're critical pollinators, they affect the global food price and availability, and they facilitate ecosystem stability. And Russia needs food as well. And I know you have really bad winters. And so you have to make sure the honeybees make it through the winter. And we can't be using pesticides all the time to make our food. So another thing that happens is we give them oxytetracycline. So the bee people have said, let's use antibiotics. Well, if you use antibiotics, you also damage the beneficial microbes. And you can tell by doing this, you can look at the number of larvae that are produced, and they call them a cap brood. And you can count these numbers and you get an estimate of the hive health. So if there's lots of brood, then you can tell the hive is healthy. Well, antibiotic exposure damages this. And if you give a probiotic, it's amazing. Look, you get recovery of the hives. In other words, the probiotics are better than antibiotics because the antibiotics are killing off the beneficial microbes. What about fish? People in Russia eat fish. You probably catch it off the North Atlantic and different places. The problem is that fish is becoming more in demand, but we're having trouble because they're dying off. And so what we did was, imagine we gave Chinook salmon some probiotics, and this is percentage survival, and I won't go into all the details, but there's a couple of probiotics that seem to improve the survival of fish. And the reason I give the examples of honeybees and fish is because food production and livestock and animal health is very important in Russia. That's where the biggest growth is of probiotics. And so there's opportunities for you to be working on that. So ask yourself some questions. What are my talents? It takes a village to teach a child. Are you good at writing? Are you good at analysis? Are you good at bench work? Are you good at people skills, multitasking? I could tell you this story about what I did in Africa, but I said to these kids, one of you is good at writing, one of you is good at presentation, one of you is good at finance, and collectively, you can form a little company. What problems interest me that I can help solve? Are you interested in solving poverty, illness, the food chain, pollution, getting cosmonauts to Mars? What is your interest? Follow your interest. What resources will I have at my disposal? Do you have a well-equipped lab? Do you have money? Do you have colleagues? Do you have basic resources, milk, cereal, animals? Is there a supportive environment? Is your government helping you? Are there government policies helping you? Is there interest from Russian companies? Are you overloaded with teaching? In other words, you have so much teaching, you can't possibly do research. So you have to ask these questions, not me. You have to ask them. Does my next step increase my future success? So what are you going to do in the next 3 years that is going to help you succeed in the future? Is it learning scientific techniques? Is it business? Is it how to teach? Whatever it is, that could be your focus. So here's my matrix, abbreviated matrix. And this is, I'm just going to close off soon. So in order for me to be successful, I had to work with surgeons, a Dutch physicist, a biologist, obstetrics gynecologist, microbiologist. I needed a technician, a biochemist, a manager, inspirational African woman, British food scientist, American probiotic, PhD student, Dutch, Swedish microbiologist. You see what I mean? It's not just me. You have to pick who it is you want to work with, and each of them has to be productive. They can't carry, they can't get publications from doing nothing. They have to contribute. So what does your matrix look like? This, of course, is the matrix, right? Is this your matrix? Where are you in this matrix? Have you got a research nurse, a clinical coordinator, a technician? Is it a scientist, a manager? What's your matrix? Because if you don't have this, it's going to be very difficult for you to succeed. And maybe you come in here as just one person in the company, but that company has to be linked to other things in society. Otherwise, that company is not even going to succeed. So in summary, when you retire, which is me, and you look back in your career and the incredible talents that you got there, that got you there. So imagine yourself right now, get to know the talents that you have, and think about what you want to do with the talents so that in 40 years' time, you can look back and say, this is what I did with my talents. Don't have regrets or wish, if only I had done a PhD, if only I had taken a chance and worked on this, if only I had done this, because you don't want to have regrets. Because if you have regrets, you wish you'd known how well you could fly. In other words, you can fly really well, but it's only you that can do it. So I wish all of you much success, and this has probably been a difficult talk for you to understand because of English and the Russian language, but I hope that you got enough of it that it can inspire you to do great things, because the world needs talented people, and we need you guys to do your best. Okay, thank you.
Thank you very much, dear Gregor. My name is Zaira. I'm your new pen friend, and we appreciate very much for so great report for our young scientists and for our students. And actually, we had many lessons about anatomy, physiology, microbiology, but we didn't have lesson how we'll be successful in our life. And your report is like very great advice for everybody from us, and I appreciate you very much. And my question is about why you choose microbiology when you were young, and how you maybe in your life you sometimes had some moments when you thought so many difficulties in science, and maybe it would be much more better to change this direction, and what helped you to overcome these difficulties? Thank you very much.
Very good. Very good question, Zira. When I was young, I studied biology, zoology, microbiology, and the reason I found zoology very interesting, but I didn't see the opportunity for jobs, whereas microbiology has so many features to it, and I always felt that because if you look at the world, and you look at humans are made up of three things. You might find this strange. Three things: skeleton, tissue, and microbes. Now, we only realized the microbes recently, but that's what a human is. And so there will always be a need to study microbes, always. And whether it's applied to the soil, to the planet, to insects, to animals, to humans, it will always be relevant. And you can now see that with COVID, it's even more important. I never studied viruses, but the people who did are now finding their careers are blossoming because they had invested in studying viruses. So microbiology is a career path that can take you in many, many directions. Now, I told you the example of the American president of microbiology, who essentially said to the world that I was an idiot and I was studying a stupid part of research. So this happened to me many, many times. People laughed at us. They thought our work was a waste of time. They didn't give us grants. But two things that kept us going. One was we truly believed that these microbes could benefit people. And so we were not prepared to be beaten by other people. And so you have to have belief in what it is you're looking at, because when things test you, you fall back on your beliefs. It's like if you have a faith, a particular religious faith, people may ridicule your faith, but you know it's strong and you fall back on that. So we really believed that these microbes could benefit women, and that's what our work was on. And it turned out we were right. We didn't get it perfect, but it turned out we were right, and that kept us going. And then the third thing is you have to have colleagues that are true colleagues, because when it comes to difficult times, you need to turn to them and say, okay, I need your help here. We need each other. And so when, this is an analogy, I don't know how this will go in Russian, but imagine you're going from A to B. There's two ways to get from A to B. One, you can go through the field that's in front of you, but the problem is the field is filled with turkeys. Turkeys, 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 all that turkeys. Now, that's the face of regular science, right? They say you have to become one of us. You have to become a turkey. You have to come into our field and do things our way. But if you do that, you just become another turkey. So what I prefer to do is, no, I'm going to go round the field of turkeys. I'm going to go round and do it my way. Well, it's a lonely road. There's no one to help you, but you know that you have the right path. And so that's what I had to do. And when you make that decision, all those turkeys don't like you, because now you're not one of them. And they'll reject your grants, reject your papers. They'll say you're an idiot. All these negative things happen. And you say, no, I'm going to get around the field because I want to be an innovator. I want to be different from someone else, from everyone else. So I think there's many, many times in your career, things like that will happen, but also opportunities will come in your career. And if you're not open to that opportunity, you'll miss it. And so I was very much open to that. Say, okay, yeah, that sounds good. Let's try this. Let's try this. This is a great idea. And the nice thing about science is, what out of the career path can you be working on humans, and then you just say to yourself, why don't we try honeybees? I mean, it's crazy. But in science, you can do that because science provides you with opportunities and skills and colleagues that can make you turn from one very different area to another one.
Hello, sir. Can you hear me? Yeah, we are glad to hear your presentation. I have two questions for you. Can I ask?
Yeah.
Okay. So you were talking about the three phases, how to become a successful person.
Now, Paul,
so,
can you hear me? Can you hear me?
Yeah.
Tell me, tell Gregor, who are you?
Okay, sir, my name is Naufal Tendat. I am from the University, North Caucasian State Medical University in Cherkassk. So I am studying in 5th year, the medical science. So my question is, how to find the right people. You were saying that we have to find the right people. So it's like an error, like a stock market method. Like we will invest some people, and if it is true, we will get the benefit. So the second question is that which of the three phases, that the three plans where you are given the three successful plans, that take the innovation from the other people, the second is be lucky, and third is plan and get the credit. So which one is the hardest, and where were you in that position? These are my two questions.
So I was number 3. I prepared. I worked very, very hard. I went with my gut feeling. When I met this urologist, I had this feeling that we had a great opportunity here. So I was 3. I was probably lucky because I met him, and that wasn't, you know, that was a chance that wasn't necessarily me. But I mean, I guess I had faith, and I don't want to talk necessarily about religion, but I think you have to have some kind of faith in yourself and maybe a higher purpose, that you're on this life to have a purpose. And if you're open to that, then when opportunities come, you'll realize that the purpose is being brought to you and you have to take it. The first question was, sorry, I've forgotten already. That happens.
How to find out the right people?
Yeah. So when I was at Glasgow University in Scotland, I noticed that the 14 graduates the year ahead of us never got jobs. And so I said, well, I wonder why they didn't get jobs. Microbiology is a great career. And it turned out that all of them wanted to work in Glasgow. Well, Glasgow is a small city. How could it possibly have 14 jobs for new microbiologists? And so I went to the careers office at Glasgow University, and I started to look at scholarships and places around the world that I could go. And I eventually got a scholarship from Rotary International, and I got the opportunity to go to New Zealand to do my PhD. And then after New Zealand, I got the opportunity to go to Canada. And people looked at me and said, oh, how did you get to go to New Zealand? How did you get to go to Canada? And I said, well, I got off my ass. I did something. Like, don't expect it just to fall in your lap. You have to go and do something and make your own opportunities. And if you are in a medical center, then look up the publications of the physicians and surgeons that are working in the place and go and talk to them. And some of them, they won't care about you. They'll not follow through. But you might find someone that says, yeah, you know, I've been waiting for a scientist. I'd love to work on this. And I can write the medical part of the grant, and you can write the scientific part, and let's work together, right? So you have to go out and search. It just doesn't come to you, right? And Dr. Bruce came, I wrote to Professor Costerton, who was on my diagram. I wrote to him in Calgary because I read his papers and I thought he was doing really interesting work. And he said, I'll get your grant, you come to Canada. And so when I went to Calgary, he said, look, I've got 2 projects I think you'd be interested in. I'm going to put you on a plane. And I went all across Canada to Halifax. And then from Halifax, I went to Toronto. This was a 2-week trip. And in Halifax, I met a physician and we had a good chat about where he'd like the research to go. And then I went to Toronto and I met Dr. Bruce, and boom, we clicked. And so I called the guy in Calgary who had brought me all the way to Canada. And I said, Bill, I'm going to collaborate with Dr. Bruce, but do you mind if I move to Toronto and collaborate from Toronto? And Bill said, sure. So he paid me. He was in Calgary. He paid me, but I was based in Toronto, and I took that chance. And it worked out great because I published about 7-8 papers with Bill Costerton. So he benefited because he got papers. And I moved to Toronto, and the rest, of course, is history. So you have to make it happen.
Thank you, sir. Thank you. We have the summary is that we have to believe in ourselves, and the luck will be coming. Yeah, I hope so.
Yeah,
Thank you.
You got to make contacts. And just because you're a student doesn't mean that a physician or a surgeon doesn't want to talk to you. But you don't go to the surgeon and say, hello, can you help me? No, no, no. You look up his papers or her papers and you read the research and you say, I have a question for you, doctor. Would you mind if I came and asked you the question? Well, what doctor is not going to welcome a student to come and ask a question, right? And then once you start talking about the question, he suddenly looks at you and goes, oh, this is a talented young student. Maybe I could work with this student. You see what I mean? The worst thing you can do is just send a cold email to someone and say, oh, hi, my name's Nafal and I want to work with you. He's going to say, who the heck are you? Like, no, it's the wrong approach.
Thank you for your...
Someone asked, what do you think could happen to nature in the future if we continue to influence insects in this way with various pesticides? I think if you've probably seen in the news in the last year that we are killing off the world's insects. It's just dreadful. And a lot of it is, I mean, I understand that a farmer has to produce enough food to feed people. And if the insects are destroying the food, the farmer is going to lose money, and therefore he or she has to produce the food. What we need to do is find alternatives to those chemicals. We're very good at killing everything, right? We're very good at blowing up cities and blowing up people instead of nurturing. And so the new generation has to look at how do we kill the insects in a way or stop the insects in a way that doesn't wipe out all of the nature. In fact, and I'll give you an example of a paper that we did. So I went to this surgeon who's now a very good friend of mine. He's a plastic surgeon. And he said, we have wounds. We treat wounds all the time. He said, and Staphylococcus aureus is the organism that always infects the wound. And he said, we just give them antibiotics and then you get antibiotic resistance and you kill all the other organisms. I wonder if lactobacilli could do anything. So we did an experiment. We published a couple of papers on this. And the concept was, if the worst enemy of a bacteria is probably another bacteria, right? Maybe a virus, but probably another bacteria. So why don't we get like negotiations? Why don't we get the bacteria called lactobacilli to come along and see if it can stop the Staph aureus? Well, it doesn't need to wipe out Staph aureus. It just needs to say to Staph aureus, no, 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 don't produce your toxin because the toxin is killing the patient. So we actually found molecules that the lactobacilli produce to make the Staphylococcus aureus stop producing its toxin. So you see what I mean? You're approaching it in a completely different way. You're not wiping out all of the, in fact, I think there's going to be studies that will come out about the hand sanitizers. We have totally changed with COVID. We have totally changed the organisms on our hands. And maybe we need to go back into the countryside and grab some soil and get recolonized again because of COVID. So look at nature and problems in a completely different way, right? I mean, antibiotics are amazing. They've saved millions and millions of lives. We need them, but let's keep them for when we really need them. And let's not use them in animals, in honeybees, and in other situations where they're not needed. We can find alternatives, and it's your generation that will have to do that.
Can I ask a question?
Yeah.
Mr. Reid, thank you very much for your presentation. I'm sure that it was useful and interesting for each of us. I read your research and I studied the effect of the gut microbiome on the human brain and effect of probiotics and on the body as a whole. Do you think, is it possible that use of probiotics affects a person's cognitive abilities? Thank you.
Yeah, so I think we're in our infancy with the way that microbes affect the body. And I think so far we've relied too much on animal work. I think there's too much mouse work, and I don't find animal work very relevant myself. I'm quite biased against animal work. I think human work is more difficult, more expensive, but it's absolutely feasible, and we should be doing more studies on humans. There was a paper we published in 2014 on breast cancer and the microbiota, and my theory was that microbes can enter into the breast tissue and potentially cause cancer, because if you are a woman who breastfeeds, you reduce your risk of cancer. And I couldn't understand why that could be. And I figured, well, maybe it's the lactic acid producing bacteria that are beneficial in the breast and therefore maybe helping prevent cancer, because when you breastfeed, there's milk and there's lactic acid bacteria. So people thought I was crazy. And we took about a year to publish this paper because no one believed it. Now, if you look at, there was a paper in Nature, or one of the Nature journals recently, summarizing all the studies that have gone on to show that we were right. And so then it comes to microbes in the brain. It wouldn't surprise me if there are some microbes, because in the breast, we found very few organisms. It wasn't like the breast was full of bacteria. There was very few. And I think possibly in the brain, there are also some microbes in very low numbers that may be doing something, and we haven't worked it out yet. And one of the potential areas is, say, Alzheimer's, or in heart and stroke patients, where a surgeon can go in and take a sample. It wouldn't surprise me if in there are some microbes. If not microbes themselves, there's certainly products of microbes that can reach the brain through the blood-brain barrier. And also, if you think of COVID, why would the brain and taste and smell be affected? Well, think about it. The nose, the back of the nose, is as close to the brain as you can get, right? It doesn't surprise me that there's some connectivity between breathing and eating and the brain. And it's just we don't understand what's going on yet. And I think the gut brain is an easy example, but there's also the lung brain. There's also the urogenital tract brain. There's all kinds of connections between microbes and things that happen in our brain. So I think we haven't got close enough yet to understanding those. We need a lot of metabolomics. What we need is metabolites produced by bacteria and then looking for them in the brain. I think the potential for influencing it is good. It will never be a magic bullet. It will never be the cure for Alzheimer's, but maybe it will, because we already know that it can affect anxiety and depression. If you give it a certain probiotic, you can reduce anxiety and depression. So we know that there are things that will influence the brain through the gut. And I think it's just a matter of time before we find some of these connections. But I think they are real. I think we will find them, because again, we're composed of skeletons, tissue, and microbes for a purpose, right? They're influencing who we are, I think.
Okay, thank you.
All right, now our time is almost over. I see some students asking just one more question about the probiotics and weight loss. Can probiotics help in controlling the overweight in humans?
Well, you know, I've seen some of these claims. I'm very skeptical. I mean, if you eat McDonald's every day and you're 50 pounds overweight, don't expect lactobacilli to lose 50 pounds. I mean, it's impossible. So I think we'll find that certain microbes do control weight to an extent. I think microbes actually tell us what to do. Like, I love milk chocolate. And so I go to fill up my car with gasoline, and I walk out the shop with a piece of milk chocolate. And I said, why did I came here to fill up my car with gasoline and I walk out with milk chocolate? It's because the gut bacteria are telling me to go and buy chocolate because they love it. So I think there's an element that definitely is the gut is influencing the brain and what we do. But you know, it's crazy to think that you'll get someone who is obese and is suddenly going to become lean. And actually, if you look back at the studies, this came from Jeff Gordon's lab, and it was all with mice. And since then, that work has been completely debunked. It doesn't make sense at all. So I'd be very skeptical about a probiotic that reduces, or it may influence your weight, but it's not going to make you lean if you're obese.
Let me ask one more, the final question from the students of ours. So, hello, I heard that you are also a writer. Is it difficult to practice medicine and writing all at once?
Yeah, because, you know, we all have lots of talents, like, and no one is the master of all talents. So if, I think there's been studies that have shown people that do medicine are, you know, highly gifted pianists or trombone players, or, you know, we have other talents, and don't let them go to waste. You may not be able to pursue them to the extent that you'd like, but absolutely you should. I started writing novels maybe 4 years ago, so I have to admit I didn't have much time for it, but I also didn't have the interest. Whereas as I've stepped more back from science, I wanted to replace that, and I love writing. So I think each of us have talents, and you have to make the most of them.
Excuse me, may I ask you one question?
Please introduce yourself. You are.
My name is Inayad. I'm from Kabardino-Balkaria Medical University, and I have maybe a tricky question, but have you ever stepped over your principles in your professional activity life?
So what do you mean by stepped over the principles?
Maybe you thought while you were a student that you wouldn't do something, but while you were working through many years, you have to maybe.
Yeah.
Well.
Yeah, actually, I don't, there may well be cases where that happened, but I don't think it was, my upbringing was very Presbyterian. I don't know if you know what that is. It's, Presbyterian is sort of Protestant, you know, and my parents had very high principles. So, for example, animal work, I didn't realize that I didn't like animal work until I did a project on rats and mice in the early 1980s. And after that, I realized I didn't want to do that anymore. And I haven't done that since. So sometimes it takes something happening to you to realize that it has gone against your principles, because you didn't really know you had those principles at the time, right? So I think that can sometimes happen. I could give you lots of examples where, for example, this guy came to us in Toronto and he said, look, I'm going to give you $1 million if you give the technology to us, and we're going to put it on the NASDAQ stock exchange, and you're going to get so rich, it'll be amazing. And Dr. Bruce and I said, we haven't proved anything yet. We're not going to put something in the market that we're not sure it works. And he said, don't worry about that. He says, we'll make money. We can tell the story any way we want. Now, I know a lot of people that would have said, great, let's go, get on the stock market. I'm going to get rich. Dr. Bruce and I said, no, we're not doing this. We have to prove this works first, right? So that's a tough decision, you know, but you have to look at yourself in the mirror and say, how am I going to live with myself if I do this, right? So there may well be cases where you've gone against principles, but in general, I've tried to stick to them, right? It's a bit like marriage, you know, when you're a guy, you're age 50 and you still feel like you're 21, right? And there's all these beautiful women in the world, and you could go and, you know, have affairs, but when you get married, you take an oath, right? And you have to stick with the oath, right? So I mean, there's many examples in society where you could go off the rails, as we say, or go against your principles. But I think in the long run, it doesn't help your life. It makes it worse, I think.
Right. I would like to thank Dr. Reid for very influential talk and very interesting explanations. And I hope all of our students who ask questions obtain very important information for their own future career and for their own future life, including. So I will transmit the unanswered questions to Dr. Reid, so he will be able to answer it via email to me, and I will resend it to the people who asked these questions. And once again, it was very kind of you, Dr. Reid, to agree to give the talk. And now I'd like to ask Dr. Haraiva to tell the final word, because he is the chair of the committee. So
thank you very much.
I'll just say before that, it's been nice talking to everyone. It's really amazing that I can be here in Canada and everyone is in Russia, so far away, and yet we can connect like this. And I noticed that all of you are inside, and I'm not getting any pictures of snow. And I thought Russia was supposed to be freezing at this time of year.
Oh, they got some snow in Nальчик.
Yeah, we have some snow.
But so, we don't have it in Cherkassk, although it's just 100 kilometers away.
So anyway, I wish you all success, and I'm sure through Vladimir I'll hear some of the success stories down the road. Okay.
Thank you very much, and it's time was finished very soon, but we have a great time with you, and we appreciate very much. And I hope that this pandemic will be finished very soon, and we will have possibility to invite you to our university and to have a real offline meeting with you and our students, our young scientists, and we are not very young scientists. We are grateful very much for your time and for opportunity to have this great advice. Thank you very much, and best wishes in future new year. 1-2 weeks and will be some good holiday, and I think that we have hopes that all our difficulties will be in last year, and we will have new opportunities and new good meetings with you. Thank you very much.
All right, take care, everyone. Thanks, Vladimir.
Goodbye, Gregor. See you soon.
Bye-bye.
Bye.
Thank you.
So I'm finishing the conference. Заканчиваю.
Отдельное спасибо большое, Владимир Владиславович.
Да, не за что. Очень приятно было пообщаться. Я надеюсь, это полезно.
Вам большое спасибо за то, что все мы, вот здесь 104 человека, и в YouTube идет параллельно прямой эфир. И вам огромное спасибо за то, что все мы, нас много, смогли послушать такого ученого. Вот уровень человека, он связан с тем, что, говоря простые слова, передается так много, и ты заряжаешься этим, и вроде бы ты все это слышал, но поодиночке, а когда вместе это все с какой-то энергией и каким-то посылом и добротой, я получила невероятное удовольствие. Думаю, что все наши молодые ученые, студенты тоже. И вам за это искреннее спасибо, потому что это ваши связи и ваше желание всем нам дать такое удовольствие.
Ваши идеи, так что вам тоже спасибо всем, и вам в первую очередь, Заира Феликсовна, потому что огромная работа была организовать все. ну, когда-то нужно начинать. Я думаю, это хороший опыт. Мы теперь знаем, как это делать. Ну, вы, в частности, я немножко.
Мы все вместе
Вот.
попробовали во всяком
Да,
случае.
да.
Да.
Ну, все, хорошо. Спасибо. До свидания.
Спасибо большое. Завтра у нас секции,
Я
пожалуйста.
постараюсь
У нас
присутствовать.
завтра хирургия.
В зависимости
У
от
нас
расписания. Да.
Да,
Вот,
актуальные вопросы психиатрии по нынешним временам.
да.
У нас завтра еще стоматология, челюстно-лицевая хирургия. И у нас завтра, Владимир Владиславович, еще круглый стол председателей секции.
Ну, хорошо. Ну, я, в общем, да, я понял.
Да.
Хорошо, все,
Всем
спасибо.
слушателям большое спасибо. Я думаю, что нам есть чем делиться, и мы поделимся еще после конференции нашими эмоциями. Пока что до завтра. Тот же логин и пароль. И завтра в 10 часов продолжаем.
Ну, спасибо.
Всем спасибо. До свидания.
До свидания. Всего доброго.